All right, I'm going to take a look at number 6, which asks you to find the 6 different trig values for the angle graphed in standard position that has a terminal side passing through the point -4, 0. Okay? And before I do that, I just want to give you a little bit more background here. Hopefully you saw my video before. The idea here is that you've got an angle graphed in standard position. Okay, it's going to look something kind of like that. And the terminal side, remember you've got an initial side and then the ending side. It's called the terminal side. Say it passes through the point x comma y. Okay? What you're really doing here is when you make your triangle, you always drop a perpendicular down to the x-axis. The reference angle is always the angle between the terminal side and the x-axis. So if you notice here, if I have a random point x, y, you're going over x, you're going up y. Okay? An angle is part of a circular motion. Imagine spinning around a circle. So this hypotenuse of this triangle is really a radius of a circle that you're rotating around. So that's why we call the hypotenuse r. Okay? So the definitions that come out of this say that, for example, if you want to find the sine of an angle, you can really just take the opposite side over the hypotenuse, y over r. Okay, remember the cosecant will be the opposite. You'll flip it and that would be r over y. If you want to find the cosine is going to be the adjacent side. It's the x-coordinate divided by the hypotenuse. That's going to be x over r. And then the tangent is going to be the opposite side over the adjacent side. That's just your y-coordinate divided by your x-coordinate. Okay, so for example, if my angle passes through the point 3, 4 here, that's creating a little 3, 4, 5 right triangle. My radius would be 5. And so my sine would be the y-coordinate over the hypotenuse. That would just be 4/5. Okay? My cosine would be the adjacent side, it'd be the x side over the hypotenuse. That'd be 3 over 5. And, you can use the old right triangle definitions. You can say, well, I'm going over 3 and up 4. I'm going to make this 3 and I'm going to make that 4. And you're going to get the same answers for your trig values. But that's where those definitions are coming from. Okay? Here's why those definitions are so useful. Because I can take situations where I have angles that I can't make triangles for, and I'm still going to be able to use these coordinate definitions, okay? And that's where question number 6 comes into play, because question number 6 gives you the coordinate -4, 0, okay? In other words, you're over here at the point -4, 0, so you've got an initial side of your angle, okay? We're rotating around the point -4, 0, okay? That angle measure there is 180 degrees, or if you're dealing in radians, pi radians, all right? Okay? We have an x-coordinate there. We have a y-coordinate, okay? You can't drop a perpendicular. If my angle went here, I could drop a perpendicular down and I could make a right triangle. But because this is laying flat, I can't drop a perpendicular down. I can't make a right triangle, okay? So this problem doesn't make any sense. What they're really asking me to do in number 6 is to find the sine or the cosine or the tangent, all of those different trig values of 180 degrees. And that doesn't make any sense. You can't have a 180 degree angle in a triangle. Normally makes no sense. But with these new definitions, it can make sense. There's your x-coordinate. There's your y-coordinate. The r is the radius of your circle of rotation, okay? The r value, just like the hypotenuse when we did these with just right triangles, the r value is always going to be positive, okay? The r value here is going to be +4. That's the radius of your circle. So in this particular case, it turns out that the radius is the same thing as the positive value of the x-coordinate. Okay, if our point was up here, the r value would be the positive value of the y-coordinate, and so on. Okay, so x is -4, y is 0, and the radius is 4. Okay, so sine is just y over r. Okay, the y-coordinate's 0, r is 4. Turns out sine of 180 degrees is 0. Okay, and by the way, you can go check on your calculator. Sine of 180 really is 0. Okay, cosine of the angle is x over r, okay? Well, the x-coordinate's -4, the r value is 4, that works out to be -1. Again, if you check on your calculator, cosine of a 180 degree angle is in fact -1, all right? Tangent is the y-coordinate divided by the x-coordinate, okay? So the y is 0 when the x is -4, that works out to be 0, okay? And again, if you get on your calculator and check, the tangent of 180 degrees is equal to 0, okay? For cosecant, the cosecant, of course, would be 4 over 0. It's the reciprocal. Remember, 4 over 0 is undefined. Okay, turns out there actually is not a cosecant of a 180-degree angle. The cosine reciprocal is the secant, okay? The reciprocal of this would be 4 over -4. That's still -1, okay? And then finally, the reciprocal of the tangent function here is going to be -4, I'm sorry, it would be the cotangent. That would be -4 over 0, and that's also going to be undefined. So interestingly, some of these reciprocal functions, their reciprocals could actually be undefined. You're going to see that occasionally from time to time here, so watch out for that. But that's kind of an overview of how number 6 works.